going to once again discuss about the power transmission. So in this chapter, we are going to discuss about the power transmission. That means transmission of power from prime mover to the machine. So that is what we are going to call as power transmission. So we have to transfer the power from prime mover to the machine with the help of intermediate mechanisms. So this intermediate mechanisms we are going to call as what? Drives. Okay, I'll repeat once again. The intermediate mechanisms which is used to transmit the power from the prime mover to the machine. So that we are going to call as drives. So there are different types of drives are there. Which are those? So we have BD, so that is the belt drive. Next one, RD, that is rope drives. Next one, CD and GD. Right? CD means what? Child drive. And RD means what? Gear. So these are the different types of drives. So that we are going to use to transmit the power from prime mover to the machine. So depending upon the application, we are going to use different types of drives. Okay. So for our syllabus, we are going to discuss about the BD and GD. Okay. So BD means what? Belt drives, and GD means gear. Okay. So next, in the gear drives, in the belt drives, so we have two types. What are those? Open BD and the cross BD. Okay. So open BD and cross BD. It is not closed BD, it is a cross BD. So there are two varieties of them. So to know about this, first we should know some terminologies. What are the terminologies? So this is a shaft which is attached to the prime mover. Is called as what? Driving shaft or driver shaft. Okay, the shaft attached to the prime mover. So that is called as what? Driver shaft. And the pulley which is mounted on this is called as what? Driver pulley, or it is also called as driver. So I need to transfer the power from driver shaft to the another shaft that drives the another shaft. So this we are going to call as what? Driven shaft. Okay, which is driven by the driver. The pulley which is mounted on this is called as what? What is this? Driven pulley. So we should know this terminologies. Okay. So next, let me explain you about the open belt drive. So when we are going to use the open belt drive, when I need to rotate when the driven shaft and the driver shaft has to be rotated in the same direction. So we are going to use the belt drives only when the shafts are parallel. I have given you the many examples. Suppose in the floor mills, in the prime mover will be one side and the machine will be placed parallel to each other. That means all the shafts are parallel. So in such cases only we are going to use the belt drives. Okay. Now I need to rotate the shaft, that is the driver shaft and driven shaft in the same direction. So that is then we are going to use the open belt drive. Okay. So this is the belt which is running over this sills. So let me mention this is A, B, this one is C and D. What is this? A, B represents A to B represents the area of contact with the area of contact of belt with the pulley, whereas C to D represents the area of contact of belt with the driven pulley. So this is about the driver pulley and this one is the driven pulley. Okay. So now if the driver pulley is rotating in a clockwise direction, so that means this driver pulley is going to pull the belt from the point B of the driven pulley. Okay. So it is going to pull the belt from the point B to A. and this will be transmitted to B to C. So the tension will be more in this side, that is A to B, the tension will be more. Hence it is called as what? Tight side. Okay, tight side of the belt. So another side of the belt, that is B to C, which will be less in tension compared to this tight side. Hence it is called as what? Slack side. Is it clear? So this is about the open belt drive. So what is the meaning of cross belt drive? So as we all know, so we will be having the driver shaft and driver pulley. So driven shaft and driven pulley. So when I am going to use this, when I need to rotate the driver and driven pulleys in opposite direction. So then I am going to use what kind of belt drive? Cross belt drive. Okay. So let me consider this as a belt and this is also belt. Okay. So this is A to B. So what is the meaning of A to B? Area of contact of this belt with the driver pulley. Next C to D. So area of contact of the belt with the driven pulley. So now this is rotating in which direction? Clockwise direction. Driver pulley is rotating in clockwise direction. And the belt will be pulled from point C. So here the belt will be pulled from point D. So whereas here the belt will be pulled from point C. So what will be the rotation of this side? So this is going to rotate in anti-clockwise direction. So therefore A to C, the tension will be more. So that's why it is called as what? Tight side. And B to B, the tension will be less. Hence it is called as what? Slack side. Okay. So this is about the open belt drive and cross belt drive. And one more important thing about the cross belt drive means that the power loss will be less in the case of cross belt drive when compared to open belt drive. Why? Because the angle of contact. So this we are going to call as what? Angle of contact. Angle of contact of belt with the pulley. So angle of contact will be more in the case of which drive? Cross belt drive. When compared to the angle of contact of open belt drive. Hence the power losses will be less in the case of cross belt drive. So due to the slippages will be very less. Is it clear? So this is about the open belt drive and cross belt. Clear again? Okay. So in belt drives, so let us discuss about the few applications of it. Okay. So applications of belt drives. So there are different situations we are going to come across when we are going to use the belt drives. So in one thing is idler pulley. So when we are going to use the idler pulley. See when this is the driver pulley and this is the driven pulley or vice versa. See the diameter is very huge difference. There is a huge difference in the diameter of the driver pulley and driven pulley. So when I need to transfer the power between these in such cases, and also in one case that is when the two shafts are very nearer. The two shafts are very nearer. So the angle of contact between the belt and the pulley will become very less. So in such cases the power loss will be more. To avoid the power losses, so we are going to use a idler pulley. Okay. So what is the meaning of idler pulley means? So without idler pulley, so suppose this is the situation. So what is the rotation of driver pulley? It will be rotating in the same direction. So this is a A to B, this is a tight side. This is the tight side and this one is the slack side. So which side the tension will be more? Tight side. And the slack side the tension will be less. In some cases, if the shafts are very near, the angle of contact will become very less. So in such cases, the slippage will be more. Slipping of the belt over the pulley will be more. So therefore, the power transmission will be less. So how I can improve the avoid the slippage means by increasing the tension of the belt, I can decrease the slippage of the belt. So I can increase the tension by adding the idler pulley. So I am going to add the idler pulley in the slack side of the belt. In the slack side of the belt. So this is the idler pulley. So what happens? So this is a belt. Now it is going to flow over this. Is it clear? So earlier it was different. So by adding the idler pulley, I am increasing the tension, and also I am going to increase the angle of contact over the pulley. So thereby reducing the slippage. So therefore I can increase the power transmission. So this is what it is called as idler pulley, and also it is called as jockey pulley. So this is about the idler pulley. So what is the next thing? Stepped cone pulley. So suppose this is the shaft. What is this? This is the shaft. I need to transfer the power to another shaft. So this is the shaft which is going to receive the power. So therefore, what is this shaft? This is the shaft is going to receive the power. It is called as driven shaft. So this is the shaft which is attached to the prime mover. And it is called as what? It is a driver. Okay. And now I am going to mount the pulleys of different diameter. So this is the diameter, one pulley. This is another pulley. This is another pulley. So in the other side of the pulley, I am going to place the another set of pulleys. This is another set of pulleys. So now I am going to pass the belt from this to this. So this is a belt. So this is a stepped cone pulley. So what is the reason behind the stepped cone pulley? Because so if I need to change the speed, I need to change the speed of the driven pulley or driven shaft without changing the speed of the driver shaft. See, you are seeing the in drilling machine, right? So the motor will be there, it is fixed. If I switch on the motor, it will be rotating at the same speed. So there is no change in the speed. The motor will be rotating in the same speed. But I need to change the speed of the driven shaft. So that I can do with the help of stepped cone pulley. So there is a velocity ratio. So in the upcoming problems, when we are going to discuss about the problems, so there we are going to come across the velocity ratio. So by changing the velocity ratio, I can change the speed. So that is the reason or principle behind it. So by changing the diameter of the pulleys, I can change the velocity ratio. By changing the velocity ratio, I can increase or decrease the speed of the drive. So this is the principle. So this is the application of what? Stepped cone. Is it clear? So main purpose is to change the speed or change the velocity. So in your bikes also you have, right? If I change the gears, so the velocity is going to increase or decrease depending upon the first gear, second gear, third gear or fourth gear. What happens in the first gear? The speed will be less, but the torque or the power will be more. So when I change the ratio, the speed is going to increase, the torque will be reduced. So can we able to move the vehicle in fifth gear or fourth gear? It is highly impossible. Okay. So when I need to move in the initial position, I need more force, but the speed requirement is very less. So that I can achieve by changing the velocity ratio. So with the help of step pulley also we are going to change the velocity ratio. Thereby I can change the speed of a driver shaft and driven. Is it clear? So next one is fast and loose pulley. So let me explain. So this is the shaft which is connected to the prime mover. So this is what? Driver shaft. Driver shaft. I need to transfer the power from this shaft to another shaft. So this is the another shaft. What is this? Driven shaft. Okay. So what I mean of fast and loose pulley means sometimes I need to stop the driven shaft. I need to stop without stopping the driver shaft. So for example, so in the traffic and so suppose you are using the bikes, the gear vehicles. So you have to stop the vehicle, but you should not stop the engine. Then what you are going to do? You are going to put the clutch, or you are going to put the gear to the neutral position. The engine will be running, but the vehicle is still stationary. How? Because there is no transmission of power from the prime mover, that is from the engine to the wheels. So that I can achieve in the vehicles by gear mechanisms. So here I can achieve with the help of what? Fast and loose pulley. What is the meaning of fast and loose pulley? So this is a pulley which is attached to the main shaft, that is a driven shaft. So there is the alignment. So this is a fast pulley, and this one is a loose pulley. What is this? This is the fast pulley, and this one is what? Loose pulley. What is the meaning of this? Means if the belt is on this fast pulley, the belt is on this is the belt. So now this belt is running over which one? This driver shaft and fast pulley. So when this belt is on this fast pulley, so there will be a transmission of power. So there will be a transmission of power. Suppose now I am going to shift this shaft or belt from the fast pulley to loose pulley with the help of belt shifter. So we are going to get another mechanism called as what? Belt shifter, which is used to shift the belt from one side to the another side. If I am going to shift the belt from fast pulley to the loose pulley, what happens? Now I am going to shift the belt from fast pulley to loose pulley. So this will be rotating, and here the loose pulley is also rotating, but there will be no transmission of power from loose pulley to the driven pulley. So simply it will be rotating. So there will be no key, attachment error. Just it is going to slide over it. That's all. Is it clear? So this is what we are going to call as what? Loose pulley. So this is the tight pulley. So what is the application of this fast and loose pulley? So when I need to stop the driven shaft without stopping the driver shaft. So then which arrangement I am going to use? Fast and loose pulley. So the power transmission takes place from driver shaft to driven shaft only when the belt is running over the fast pulley. Okay, so there will be no power transmission when the belt is running over driver pulley and driven pulley. Okay, when it is on the loose pulley, there will be no power transmission. this is about the application of fast and loose. Is it clear?